Hello, everybody, and welcome to session 6 of Glow Your Own. We've learned a huge amount of stuff, and it's great to reflect on what we've been picking up over the past few weeks. But this is the final concluding session where we get to put kinetic activity, so a robotic motor, into your circuits. So, as usual, we've got Sophie from STFC, Rutherford, Appleton Laboratory, and we've got James too, who also works at STFC, Ral, and I'm Dane. So I think we're just going to jump into it and get into some coding, if that's all right, Sophie.
I think so. I will just say, before we get started, that Vicky says hello to everybody. She's so sorry that she couldn't be here for this final session. She's in London at the moment doing some really important stuff. But she would particularly love to see photos of anything that you have done because she won't be around today. So if you do have any photos of your circuits or your code, please do send them in. And we've just had a message from Sarah, who will be joining us shortly. Okay, so you're ready for some coding. Like Dane said, we are going to do some motors today, which is very exciting. Always good to get things moving, which is fab. We're also going to do some new coding things, use some new kind of commands and instructions in the coding part, which is always my favorite bit. So that's really good. All right, I'm just going to share my screen with you so that we can get started. Like always, we're going to start with Tinkercad. We're going to get it working on Tinkercad, and then we will transfer it to our physical Arduino. Okay, so let's log in. And I've already forgotten what the thing is. It's 2025.glow. Is that right, Dane?
That's right,
001. So I think, Dane, if you could pop the link in the chat just in
the
case
Tinkercad
people
link is
do.
in there, so please sign in to your Tinkercad code.
Brilliant. So we've got all of our lovely previous circuits. We're going to start a new one today. You can just carry on building on the circuits if you'd like, but just to make it really clear which is the new bits and which are the bits that we're doing today, I'm going to create a whole new circuit. So I do create and then circuit. First things first, I'm going to call it something sensible. So I'm going to call it GYO, not FYO, GYO session 6 motors. So now I will always know what my circuit is. So just like normal, our first two components are going to be our Arduino and our breadboard. So I'm going to go over here to the right and collect my Arduino. Pop that here. Oh, it's really big, isn't it? I'm going to just zoom out a little bit so we can see a bit more. And then I'm going to get my breadboard over here like this. All right, so now we've got our two main components, our controller, our microcontroller, our Arduino, and our breadboard. Now, today we are going to use some servo motors. So there are different types of motors that you can use, but you should all have a servo motor, which is this one here. It's called a micro servo. And if we switch our view of our components, so up here on the right-hand side, we'll see a little bit of explanation of what it is. So this is a motor whose position can be controlled using a microcontroller. So if I pull this out here, I can just pop it by the side, and you'll see it's got this little kind of cross piece on it, and so we can tell the motor exactly how far around we want that to be rotated. So we could say we want it over like this way, or we could say we want it like this. So it's a really helpful component. And you'll see that it's got three little pins or three little holes. And really helpfully, Tinkercad gives you a bit of a helping hand, because if you hover over each of the holes, it tells you what that needs to be connected to. So if you hover over this one, it says ground. If you hover over this one, it says power. And then if you hover over this one, the final one on the right-hand side, it says signal. so we know what we need to connect each of these two. Now, you'll see in a minute when we're doing it with the real servo motors, which look like this, that it can be a little bit trickier to figure out which one is which, but we can talk about that in a minute. So we're going to do a really simple circuit to start with that just connects up each of these different pins on our servo motor to our Arduino. So let's start with the ground. So that's the one here on the left. So I'm just going to move it down a bit. So I'm going to click and go from the ground up to my breadboard to the one next to the blue line here. And I'm going to use the same wire colors as I used before. So because it's going to the ground, I'm going to use orange. Or maybe brown. Should I use brown? I kind of switch those up. Okay. And then I'm going to connect that row on my breadboard, this ground row, this blue line, to the ground on my Arduino, the one that says GND. So I'm going to use another wire and connect to the ground here. Okay, so now my Arduino is connected through my breadboard to the motor. We could connect the motor directly to the Arduino, but because hopefully we'll be having some other components, it's useful to do it through the breadboard for now. Okay, next up, we want to connect the power to the motor. The motors need power from the Arduino. So I'm going to use another wire to connect the power from the Arduino to the red line on my breadboard up here. Oh, that wasn't very straight, was it? And like normal, I'm going to make that a red wire because it's going to the power. Okay. So now I've got a line from the motor to this red line on the breadboard, and then I'm going to go from the red line on the breadboard to one of the power things on my Arduino, which are down here. And we're going to use the 5 volts one just here. Okay, so if I zoom in a little bit just so you can see, that's connected to the 5 volts on my Arduino. Oh, oh no. Now my lines aren't straight. There we go. That's better. It's important. Dane's grinning at me.
It's good. It's good.
I like my lines to be straight.
It's good.
Yeah, I think so. All right. So the final thing, and then we'll pause for a second before we do the coding, just to make sure that everyone is caught up. So now we've got power, we've got a complete circuit, we've got power, and we've got going back to the ground, but we need to be able to send instructions out to the motor to tell it where we want to go. So I'm going to go from the signal, the final pin over here, and I'm going to go to pin 2 on my Arduino here, so I can send out instructions. And because we're sending out instructions, I'm going to use a green wire, like that. Okay, so now we've got a complete circuit. We can send instructions out to our motor, it's got power, and it goes all the way around. So how are we doing, everyone? Let's have a pause so that everyone can make sure that they've got that circuit. Give me a thumbs up when you've drawn your circuit. But like always, remember, don't worry. It doesn't really matter if you're not quite keeping up, because you've got the worksheets that will tell you exactly how to do every bit. You've got the recording. You can also stay behind, and we can do some troubleshooting at the end. So there's plenty of chance to get caught up. Okay, great.
Sometimes it's nice just to even watch and then do it later on by yourself. I sometimes find, or some people would say, like,
I find that too.
Nice to watch. Always nice to make along. It's up to you.
Yeah. Okay, so I can see that some of you have got your circuits all ready. Fantastic. Anyone else got the circuit? Yeah. Sorry, my words got all jumbled up then. Give me a thumbs up if you're ready to do the coding parts. Brilliant. I can see that some of you are. Fantastic. Great job, everyone. Also remember that if there's a bit that you didn't quite understand, for whatever reason, maybe your internet glitched out, or maybe I explained it really badly, you can pop something in the chat, and James and Dane can help you out. Or if you just want them to check that your circuit is right, then pop something in the chat and we can go and have a quick look for you. All right. Now, my favorite part of it, we're going to do the coding part. We get to use some new commands today, some really, really useful commands. So, like always, you click on the code button up here on the right, and then you get this code. Tinkercad's like, would you like to do this? No, we still wouldn't, Tinkercad. So we're going to delete that, and we're going to start our own code. Now, this is the new part of the coding, the new things. We are going to use something called variables. Now, variables are really, really, really useful and important. I'm sure James uses them in his code all the time. They're really simple. They're just a way of getting the computer to remember something. So say it could be the variable was your birthday. And so you could say, computer, I'm going to make a variable called birthday. My birthday is August. You need to remember that. And then the computer will remember that, and it can use that in all of its code. Or you could say, okay, computer, it is 25 days till Christmas. I know it's not 25 days till Christmas. But you could say days till Christmas. You could have a variable called days to Christmas, and it would remember that. And then you could say, all right, well, computer, every new day, I want you to take off one day because it's getting closer and closer to Christmas. So they're really, really helpful. And Tinkercad can do them. Arduinos can remember them. And they are just here. So you can see this purpley dot called variables. So we're going to click on that, and we're going to create a variable. You can create as many as you want, and you can call them whatever you want. But just like when we name our circuit, it's normally a really good idea to call the variable something you're going to remember easily. Remember what it is easily, because for this one, we're only going to have two variables. But when you're doing big code like James uses, he'll have hundreds and hundreds of variables in there. And so it's always really helpful to call it something sensible instead of like temporary or thing or my code isn't working, please help, which I have called a variable that once. But there we go. All right, so we want to create a variable, and what we want to create first is we want to create a variable that gets the computer, the Arduino, to remember the angle of the servo motor. Okay, so that's the angle that this bar is going to be at. So we're going to create a variable, and we're going to call it angle. Okay, and then you type it in, going to click OK, and then you get these options, and you can do whatever you want with them. You can set them to different values. You can change them as well. So we're going to start off by setting that value to start with. So we're going to say at the beginning of our program, we always want the motor to be upright like this. That's an angle of 0 degrees. So if you go to Control here, you can click on Start. So at the beginning of any program, it will set these variables. So we're going to say on Start, then we're going to go to this variable and say set angle to 0. Now I want it to be set at 0 because I want it to start like this. But if I wanted it to start, I don't know, so the long bit was over here, I could change that to 90 degrees. I could change it to whatever I wanted. So you could do that, but I'm going to keep it at 0. And what we want to do is every second, say, I want my servo motor to move just a little bit. So I want to move it by a certain amount, and that amount I'm going to make a new variable to change it by. So I'm going to create a new variable, create variable again, and I'm going to call it change. No, I'm not. I'm going to call it difference. There we go. And so here at the beginning, I'm going to set what amount I want that angle to change by. So I'm going to do that up here. So you can do set angle. You can change it to any of these different variables. So set difference. And I'm going to say 15 degrees, I think. So every second, I want the angle to change by 15 degrees. Because I've set it up here, that means it's really easy to change later on. Okay, how's it going so far, everyone? Lots of new concepts in this one. So please do pop a question in the chat if anything doesn't make sense or you want us to go over anything again. Okay. Fab. Right, now we're going to do the moving part. So let's go to control again, and we're going to do a forever loop. Okay? Because we want every second, we just want to change the angle of the motor. Okay? So we want to send a signal out, send an instruction out to our motor. So if you go to output, because you're sending stuff out, you'll see lots of ones that we've already used. So set pin to high, we've used that one. Print to serial monitor, we've used that one. The one that we want to do today is this one here that says rotate servo on pin 0 to a number of degrees. So we're going to put that in here. Now, first things first, I want to make sure that my instruction is going out to the right component. So you'll see that my motor is connected to pin number 2. There you go, connected to pin number 2. So I'm going to change that to 2, like that. And then I want the angle of my motor to be my variable called angle. So I'm going to go to variables, and you can see I can pull out the one that says angle and just pop it in here. Okay, so it would set it to angle. But then I want to change that angle. So the next second, I want it to move by 15 degrees. So I'm going to use this command here that says change angle. And pop that here. And the amount I want to change it by is my other variable that we've called difference. I'm going to pop that in here. Okay? Makes sense so far? Now, always a good idea to keep track of things. It'll help us understand things. So what I want to do is I'm going to go back to output next and say, just print out to our serial monitor what angle we're supposed to be at. Okay? Oh, I'm just going to move this here. Okay, so print to serial monitor, and I want to print that value angle, right? Okay, and now one last command, and then we'll have a break, make sure everyone's up to speed. And that is computers are much quicker than us, much, much, much quicker than us. And you'll remember when we were doing flashing lights, we had to put in a little wait command because otherwise the light would go on and off more quickly than we would be able to see with our eyes. So what I'm going to do, I'm going to go to this control section here, and I'm going to use the wait command, and I'm going to wait. I might wait for, no, I'm going to wait a second before I move, okay? All right, and that is all of our code. So some big new concepts there, but once you get your head around it, variables, most useful thing that you can, they're really, really helpful. very helpful. I do like them a lot. So how's it going? Remember, we do have this all on a lovely worksheet for you that Dane sent out. All right. So ready to simulate and test things out. Right. So just like normal, we're going to press start simulation and then cross our fingers and hope that it works. All right. So let's go. Start simulation. If it works, my motor, sorry, I pointed at it with my finger on my screen, which is not helpful. For this, oh, sorry. Oh, there we go. If I've done my coding right and my circuit right, my motor here, you should be able to see it moving in just a second. So let's try. I'm going to move my serial monitor up as well so we can keep track of the angle that it thinks it's going at. So 3, 2, 1, and go. Thinking about it. Oh, and it's moving. It's moving. It's moving. Yay!
Brilliant.
Fantastic. All right. And so my servo motor has worked. That's brilliant. But you'll notice that it moved up to here, up to 180, and then the servo motor stopped working. And that's the thing that servo motors do. They can move around 180 degrees in either direction, but they can't go further than that. They'd get all tangled up inside. So we probably won't have time today, but you can have a think about how you might want to change the code so that when it got to 180, it moved back on itself rather than just stopping dead. There is some code in the worksheet that will help you do that. Have a go yourself if we don't do that today. Okay, so now we have our beautiful working circuit and we are ready to move to our real physical Arduino, which is always fun. Okay, so I'm going to stop my share. Oh no, first I'm actually just going to check and see how you're all doing. Did that work for you? Give me a thumbs up or something if it's working. Don't worry if it's not working. Lots of new concepts today. And so you can always pop something in the chat to see, to get some help. And we can also help with the troubleshooting section afterwards, as well as you've got the recording and the worksheet. So you're all set. Okay. All right. I'm just going to close my serial and hold out just for a second so that you can check that you've got everything on that screen. If you want, you can also take a screenshot of the screen share so that you can see just that bit and keep working on it while we are making our physical circuit. All right. Great job, everyone. Okay. All right. So my screen share has stopped and I'm going to open up my Arduino cam. Here we go. And I'm going to spotlight that so everyone can see, well, everyone can see the breadboard. And then if I move my Arduino here, you can see the Arduino as well. Okay, now first up, I'm just going to show you the servo motor. So this is what your servo motor might look like to start with. It's got all of these different bits, and then it's got these 3 wires coming out that normally has a little 3 little pins, just like on Tinkercad. It might look slightly different to that in yours. It might be a different color, for instance, but they will have these 3 pins coming out. And then you also will probably have something like this, which is those little blades. They often come separately in the pack, but you can just pop it on the top like that, and then it will move around when the servo motor moves. Okay. Now, I said that Tinkercad was really helpful because you hovered over each pin, each little hole, and it told you if it was meant to go to the ground or the signal or the power. Now, there's no labeling on mine. Some servo motors do have a nice little label that tells you which one is which. So there isn't any labeling on mine, but you'll see that the wires that come to it are different colors. Okay? So different colored wires going to each of the different holes. Now, you can normally tell by the color of the wire what you're supposed to connect to it. So I've got 3 wires, a black one, a white one, and a red one. It's absolutely okay, whatever color your motor is. They just come in different colors and packages, but they'll all have these three wires.
I think the servo motors that most people will have the same color scheme as what there is on Tinkercad. So the Tinkercad version of the servo motor has slightly different colors.
It does, yeah.
So if you need to match up with what the Tinkercad, or if your servo motor matches up with the colors on the Tinkercad servo motor drawing, follow those ones.
Yeah. So for me, I've got 1 black wire, and that is my ground. Now, yours might be a brown wire, like it was on Tinkercad, and that would be the ground as well. I've got 1 white wire, which for me is the signal. And on Tinkercad, so maybe on yours, it was orange. It was an orange wire. And then I've got 1 red wire, and red is power. So it was kind of a dark red on Tinkercad. Okay. So I've got a red wire for my power, I've got a white wire for my signal, and a black wire for my ground. Okay. So I'm just going to connect those up. So my red wire, my power, I'm going to put a red wire in it. There. Oh, like that. I'm just going to put the wires in first because it will be hard for you to see all of the different bits at the same time otherwise. Really helpful if you've got the exact same as Tinkercad. Mine's just irritating and different. So my white wire is my middle one, and that's my signal. So I'm going to put a green wire into that, like that. Oh, it can be a bit fiddly if you've got a long wire, so you just have to pop it in and be gentle with it. And then I've got a ground wire. So I'm going to use my orange ground, which is the black one here. Okay. So they're all connected up like that, like you can see. But yours might well be like Tinkercad. Do you have a Tinkercad one, Dane?
I have the same. Where is my here we go. I'll turn on my Tinkercad cam.
There you go.
So this is so mine has the same. This is hard to do. It's a bit of blue tack. There we go. So they're the colours that I've got on mine.
Brilliant.
Which I think match up with what the servo motor is like on Tinkercad.
Yep, perfect. Thank you, everyone. So yeah, so the brown one, that's probably the ground. The red one is the power, and the orange one is the. Thank you very much, Dane.
There we go.
Brill. All right, so I'm gonna unspotlight that one so that we can create ours. So here I've got mine. So I'm going to take my signal, which is my green wire, and I'm going to put that into my Arduino. Now I used pin 2, so making sure it's in pin 2. That is connected. Oh, that is connected there. And then I'm going to connect via my breadboard. And I've just pulled out all of the wires from my servo motor.
Oh, rats.
Yep. So there we go. There, that's better. So now I've got the orange wire, which you'll remember was connected for me to my ground of my Arduino. So I'm going to put that on the blue of my breadboard. And then the red wire, the power, I'm going to put that on the red line in my breadboard, like that. Okay, so you can see those. And then I'm going to connect those up to the Arduino. Okay, so let's do the ground first. So you'll see here is my ground on my Arduino, GND, and that goes to the blue line on my breadboard. So that's all connected up. And then the red line on my Arduino, I'm going to connect that up to the power, to the 5 volts on my Arduino, which I always find quite difficult to find. Oh, there you go. So there, that's all connected up. Okay. All right, and I'm just gonna, there we go. All right. So how was that? Little bit fiddly because the motor keeps falling out. My motor keeps falling out. But hopefully yours is behaving much better than mine. I really like Dane's idea of sticking it with blue tack to the table because that just
I'm going to do that now for all the time.
Yeah, that just helps to move things around.
To calm it down a bit. There's oftentimes a
Yeah,
lot of wires and a lot of components all wriggling around.
exactly. Here we go. And hello, Sarah.
Hello.
We're all good. Hi. We've been doing variables, Sarah. It's always my favorite bit.
I love variables. I'm very excited.
All right. So we've got our Tinkercad. We've made our real circuit. Like I said, don't worry. You can always pause us and watch the recording. And now we need to take our code and send it to the real Arduino. So just like before, this bit is exactly the same. We're going to go to blocks and we're going to change that to blocks plus text in our Tinkercad code. And then we've got our lovely blocks and it's translated into this other language, the C++ language. So I'm going to copy all of that, Control A, Control C, or you can do right click and press copy. Then go to the Duino app. If someone could pop the link to the Duino app in the chat, that would be really helpful.
Yeah, doing that now.
Thank you very much. All right.
Keeps
and then head to code on the Duino app because that's what we want to do. And then in here, so I've already been doing some Arduino this today. So you'll delete whatever was in there and we're just going to copy in our new code. So you can see I just did Control V and then I've got my lovely code that we wrote in Tinkercad here. Okay. Now, this is the bit that is new for this because we're using a servo motor. We're going to use something called a library. Now, libraries are really, really helpful things because in order to control things like motors, you actually need quite a lot of sort of behind the scenes, making sure that the Arduino knows what it's doing and that the motor knows what it's doing. But some people have helpfully written all of that for you, and you can just say, well, I just want to use that code that they've done. So if you click up here on the left, you can see this button called Libraries. So if you click on that, then there's all of this lovely code that people have already written for you to do lots of different things that will just help you and make your code a lot easier. Now we want to include the servo code. So if I click on this here in the search button and then type servo and then click search or click enter, you'll see that there are some different things that it can do with servos. So I'm just going to click on this. So you click on the one that says servo, first one up at the top. Then over here, you can click add. Okay. And that just tells the Arduino that all of that thing that was in this library that somebody else has kindly written for us, it uses all of that code to understand how to talk to the Arduino. Okay. Now I'm going to go back. This bit here says include servo.h. Think about all of that code. Now, remember, you need to select your Arduino. All right, so down here on the right, you can do serial selected, serial select. You click the one that says USB serial device, might be different for you, and you click connect. Then it should say serial connect. All right. Like that. And then we try and send it. Now, I sent mine to my Arduino a little bit earlier. So I'm just going to, shall I turn on my Arduino cam? Let's spotlight that so you can all see it working. Remember that we're going to send, we're going to press this one, compile and upload. It's going to think about it. So I've got 100% error because it's got grumpy with me. But that's okay. We'll do compile and upload, and we will send it to there. So let's just remember what we do when we get this this error. What I'm going to do is I'm going to close my. I'm going to stop my share. I'm going to close the browser. Now that's closed. I'm going to open a new one, a guest profile. I'm going to share that with you. You see, this does happen to everyone. It just gets grumpy with you sometimes.
It does indeed.
Yeah. Let's go to the Arduino app. Okay. Let's go to code. We'll create a project. I'm going to call mine motors GUIO6. Create. And I'm going to paste all of my new lovely code. Then I'm going to do the same thing with the libraries again. So I'm going to go up here to the top left, click the libraries. I'm going to search for the servo. Click on it, press add. There we go. So I know that's added now. Back to the code. Let's select our device. USB serial. Connect up. And then we're going to compile and upload and really, really hope it works this time. Cross your fingers. Yeah.
Hey.
All right. And now you can see my servo motor is moving around just like it did on the Tinkercad. And then it's stopping at that. And I will show you, I'm just going to stop my share for a second. I'll show you a thing I can't remember if we've talked about it before. You can see here on the Arduino, there's the connection to the computer. There's this little button here, and that just resets it and sends it back to the start of the code. So if I press that, sorry, I need Dane's blue tack, so
Right.
as well.
So I'm just doing, I've got mine set up too. So I've got my little, is it like if I can help?
Oh, yeah, sorry, it's I moved it around. There it's going around, and then I press the button.
I'm doing it
and
too.
Reset.
So reset. There we go.
Fantastic. All right,
I've
let's
lost my
see. Dane's
helicopter, so I've
is
made an
yours
arrow
working?
out of paper.
You've made an arrow. I love it.
Because I've lost my helicopter plastic thing. So there we go. Press reset, and there we go. Look at that.
Fantastic.
So if
And
I had more
now,
time, I would have put a little LED on the end of that arrow using my extension wires from last time. But maybe that's a project for me later.
I think that would be a fantastic project for you later, Dane. Really, really great. So, how has that gone, everybody? We did do that last bit pretty quickly because mine stopped working. So don't worry if it's not moving around.
So we've got a couple of people that seem to be very happy with it. I'm assuming the bread is success. Breadboard's a success.
Absolutely, yeah, definitely. I think that counts.
Brilliant.
There are other ways that you can send your Arduino code to your Arduino. There's something called the Arduino IDE, which you can download if Arduino isn't working for you. So there are other ways of doing that. But well done, everybody, for getting that to work. That is brilliant. That's absolutely fantastic. Right. Well, I think we've got 5 minutes, which means that I think we can do one little extra thing on Tinkercad. Do you think so, Dane?
I think let's go for it. Let's go for it.
Now, and I think let's be ambitious. We can do this, everyone. Well done, honestly. Don't worry if it's not working quite right. That bit is really tricky. You saw how mine kept not working. So let's go to Tinkercad. Oh, I'm going to have to log back in again. Oh, give me a second, everyone. And I'll share my screen. Oh, there we go. I've got the Arduino app. Now let's share my screen and let's try and log on to the Glow Your Own one. Sorry, I'm just getting the link. There we go. La la la. Glow dot. No, it's 2025, isn't it?
That's right. Yeah.
We go, and here is my circuit all ready for me. Clicked on that one, and I knew exactly which one to go because I called it something sensible. There we go. All right. Now, I think what would be nice. Well, let's ask all of you. Would you like to control the motor using a distance sensor or using a light sensor? So pop in the chat which one you'd prefer. If you want to use the other one, the one that we don't do, that's completely fine. The same principle will be the same principle. And I should say that Dane and Sarah, we've never actually made this circuit live, or even not, so it might not work. Because the first time you do stuff often doesn't work, does it?
Sometimes it doesn't work. We might be lucky. We
might be lucky.
But
it's true. We might be lucky. That would be fab. All right.
I think
okay, well,
I think the proximity sensor has
the proximity sensor is working, is the one that's okay. Fantastic. Well, then let's use the proximity sensor, shall we? Now, that means we need to change our component list to all, because you remember our distance sensor was not in the basic list. Let's look down and let's find our ultrasonic distance sensor over here. And let's pop that on the breadboard like that. Okay, so ready for that? I might zoom in a little bit because it's a little bit small, isn't it? There we go. All right, now my distance sensor needs some power, VCC. So let's connect that to the power one, which is my red line. And I'm going to turn that red. I need it to be connected to the ground. Oh, so I'm going to connect that to the ground, and I'm going to make that orange. We are going to do this pretty quickly because we don't have long. So we're just going to see if it works. And so you have to very much cross your fingers for this bit. And then we're going to connect our one that says trig to pin number 11. And we're going to send get information. So that's a yellow wire. And then we're going to use our other one that says echo. And that's going to go to pin number 2. And just to make it easier to distinguish, I'm going to make that a turquoise wire. Okay, so now our connection is all sorted. Now let's look at the code over here. And instead of changing it to this variable called angle, what I'm going to do is I'm going to set angle to whatever the distance sensor tells me. So we'll see if that works. Okay. Now you'll remember that we wanted to, well, if we wanted to read in our distance sensor, we had to use input. And you can see read distance sensor here. Let's, instead of, and so that's what we're going to set our angle to. So let's go set angle to, and instead of a number here, we're going to use the input from our distance sensor. Now it's a really long one. So remember, we've got trigger on pin 11 and echo on pin 10. Okay. So now, and then I'm going to take out this bit here. And we're just going to see if that works. So I'm not going to change the angle. Oh, maybe let's change the angle. Why not? We'll do that. Okay. So now, instead of having just a number that I set, it's going to be the number of the distance sensor. All right. Never tried this before, so we'll see if it works. Like I said, we're doing this really quickly, so please don't worry if it doesn't work, because I'm not convinced. I'm not sure it'll work. Okay. So let's do a start simulation. Cross your fingers, everyone. Okay, and now we click on the distance sensor. Oh, let's click on the distance sensor. And you can see, how does it say? It says 104 centimeters. And now if I move it down here, 43 centimeters, it's moved to there. All right. Now let's change the distance sensor. And
I think that has worked.
I think it's worked. Hooray! Oh, marvelous. Who says you can't do it on the fly? So I could change this, and if I make it smaller, see my servo motor moves to the bottom. If I make it bigger and bigger and bigger, it moves up. And if we clicked, oh, let's stop the simulation for a second. If I clicked on the serial monitor, we'd be able to check what value it's meant to be at. So now it's on 86, 87, about 90. Let's move it and make it bigger. And it's getting further away. But if I make it smaller, it turns back. Oh, fantastic. What a lovely way to end. All right. So That was super, super quick. So don't worry at all if you didn't get it. We will share the recording and we might add that into the code worksheet that we can send out to you afterwards. And I think that is it for our end of time. I'm so impressed, everyone, with all of the amazing work that you have done. Thank you so, so much for working so hard and keeping trying, which in coding is always the most important thing. Persevering is just the most important skill that you can have as a coder. So thank you so much. Well done. You should be very proud of yourselves. And I'm going to hand over Dane to Dane to finish us up.
Oh, Sophie, that was amazing. And well done for giving it a go. And we absolutely applaud all of you for giving it a go. So if you have an idea of making something, a little Google search with this basic knowledge that you've accumulated over the past few weeks. And as you've seen with Sophie tonight, sometimes it doesn't work first time, you have to fix it. And then sometimes you have an idea and want to give something a go, and it just happens to work, which is just perfect. So really nice end. Well done, everyone, for joining in all the time. Thanks so much, Sarah and James, also for kind of being involved in the background. It's been really helpful to have you on the chat and helping people out here and there. I think all of our people who have joined this year have been great, and it was so nice to see a couple of Glow Your Own coders in real life last week at the Light Festival, and I saw someone make their egg box flashing light thing from scratch. It was brilliant, so I'm really proud of you all. That's it for us this year. The festival is over. This is the very final event. If you want to pick up your Arduinos at any point in between now and next October, go for it. And if you've got some really great ideas, please do share them. And email to info@if-oxford.com would be a great thing for us to see with your progress photos of your constructions. And if you don't happen to do any coding in between now and next October, do join in. It's very, 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 very likely we'll be running Glow Your Own in a similar way next year. So you can always pick back your Arduinos and get back involved. But I think from the team, it's really nice to say cheerio to everyone. So if everyone wants to unmute, and we could all shout goodbye for the recording.
Bye.
Goodbye, everyone.
Bye.
And then
Well
we'll
done.
do, yay, well done. Okay, I'll start the recording and we'll do the troubleshooting part now.